Live.
Okay. Good morning, everyone. Today we have joined this webinar on the topic of carbon capture utilization and sequestration with our expert, Ketki Nagpure, who is working as a modeling engineer in Engineer Road Technologies Private Limited. She completed her graduation in BTech Chemical Engineering from RTMNU in 2017, and she has an experience of nearly 4 years in the industry. She has successfully designed an absorption and stripping column using S1 Plus. She has also analyzed various techniques for energy reduction during CCUS, which is the topic of the webinar. She has contributed in research while working for Defense Warhead. She is also trained in HRA and head of study. She has contributed in the implementation of TPM and laid fiber stream of the department. She has also published a book in the Wiley publications, which is titled as Nanomaterials for Remediation of Selenium in Water. So we would like to welcome you, Kethi
Thank you,
ma'am,
sir.
and I would like to hand over the session to you.
Okay. First of all, very good morning to all respected faculty and all dear students. Thank you for inviting me. It's my honor to be here. As my intro is well given, now you all know me. So I would like to ask, how are you all? Are students there, sir?
Ma'am, actually, they are watching through the Facebook Live.
Okay, fine. It will not be interactive, right?
Yeah,
Okay,
they will send the questions to me, and I
They
will.
can listen me only. Fine, no problem. So it's great. So today I'll be introducing you to a very new, very advanced and important topic called CCUS. CCUS is nothing but carbon capture, utilization, and its sequestration or storage. CCUS is a technology which is in great trend right today. And globally, at least, it is in great trend. So let's move on to our first slide. Here we can see, first of all, I would like to ask what is the statement for the first law of thermodynamics. Energy can neither be created nor be destroyed, but it can be transferred from one form to another, right? Everybody is aware of this law. So human in the need of fulfilling their amenity and bringing advancements has taken advantage of fossil fuel to generate energy. We have generated energy from fossil fuels. First, we have converted it from heat to mechanical energy and then mechanical to electrical energy. In this way, we have transformed energy from one form to another, right? But in the race of bringing the advancement, we have neglected the adverse effect causing to our environment due to this fossil fuel. The first thermal power energy generation has been generated in 1882. Energy generation via first thermal power plant has done in 1882. And almost after a century, in 1972, we have realized that it is causing great harm to our environment. And since then, the race has begun, which is called as CCUS. CCUS is a technology that can capture CO2 mainly from the environment and utilize this captured CO2 from some better purposes to make some value added products which we could utilize and make the world carbon neutral. So because why we are transforming this energy from one form to another? Because as it is the form of energy, we cannot destroy it. So the only aim of ours is to transfer it from one to another phase. Today we will see what is the role of CCUS in mitigating the climate change. So as everybody of us are aware about what is greenhouse effect and what are greenhouse gases. So carbon dioxide is the main culprit in the greenhouse gases due to abundance in nature, as it is present in abundance in nature. Nowadays, we oftenly hear that from the scientists or experts or from the media, we hear that some plant or some animal is on the verge of extinction. Why it is happening? What is the reason behind it? Here is our sinister. CO2 is the main sinister, whatever is happening around the world. Whatever adverse and worse worse things are happening around the world. Here on the right hand side, we can see the number of disasters, natural calamities like floods and droughts has doubled since last 2 decades. After several studies, experts have found that since 2000, the reported disasters has doubled in number. The number of deaths caused in millions has also increased. The number of people affected due to floods, droughts, and other natural calamities also has increased, and so do the economical losses. And the main reason behind this is the carbon dioxide. Because carbon dioxide is affecting to our environment and earth so adversely, it is leading us to the adverse effects. United Nations Environment Power Program is an organization, according to this, which is broadly known as UNEP. According to UNEP, our generation is the last generation that can treat or that can save the future generation from the climate change. After our generation, there is no way out. Here in this graph, we can see the roadmap of carbon dioxide emission reduction. Some experts, after several studies, have came to a solution that if several parameters has been followed and several way outs has been drawn, such as CCUS, usage of green fuel, bioenergy, and electrification, we can reduce the CO2 in this manner. This will be the roadmap if this amount of this parameters has been used. If CCUS will be used, then we can reduce it up to 2070. The effect will be not very quick, just because many research and gaps are still needed to be filled. So it will lead us a very small effect, but it will be beneficial for us, and we can save our globe. So electrification also we have to do if the process is either carbon neutral or carbon sink. Greenhouse gases. As I said earlier, greenhouse gases are the major contributors and the main villain. Who is the main villain now? Other gases are also similarly responsible, but as methane, nitrous oxide, etc., other greenhouse gases are present in very less quantity around the globe. It is not leaving that much effect as compared to CO2. As CO2 is present in abundance from the point sources or non-point sources, which are identical or non-identical, it has leading a great effect. The main sources of carbon dioxide are fossil fuel combustion power generation, transportation, and domestic heating, cooking, and even this vehicular emission that also comes in transportation. So here the main culprit is carbon dioxide again. Now, what is global warming? Global warming is nothing but a waste disposal problem. Our poor waste disposal management or waste disposal management is not aligned, I would say, that is leading to cause the global warming. India is ranking third with a number of 36 billion ton of CO2 emission per year, and it will continue to increase if any action is not taken now. So there is a serious need to take some action, and these smart brains like you, the new brains like you students, you can do something, you can find some solution to treat this. Paris Convention is an agreement for the global industrial property. Paris Convention is the agreement for the global industrial property. It has adopted it in 1883, and now India is a member of Paris Convention. According to Paris Convention, the global temperature should not rise above 2 degrees Celsius as compared to the pre-industrial time. But our studies shows that it will rise up to 3.1 to 3.7 degrees Celsius as compared to pre-industrial era. So we have to achieve this goal by 2050. It has the agreement. The agreement has been made up to 2050. We have to at least start or at least discover some technologies that will be able to make our environment carbon neutral. we have to achieve this goal completely by 2100, from 2050 to 2100. Okay. Here in this graph, we can see the annual generation of CO2 globally from fossil fuel only. Since 1990, the annual global emission of CO2 has increased from 22 gigatons to 38 gigatons. It has almost increased by 50% since last 2 decades. It is a very serious problem. What will be the scenario in this running decade? If it will not be treated, then it will leave some major effects for future generation or for our further generations also. During this whole time, since 1990, the global CO2 emission has fallen only twice in 2 decades. In last 20 years, it has fallen for 2 times only. That is one in 2010 due to global financial crisis, and that is to only by 1.2%. And another second time it has fallen due to COVID pandemic, that is by 5.4%. So do we need more global crisis or more pandemic to treat the CO2? Are we in the need of pandemic or crisis? No, definitely not. We don't need the pandemic or crisis, but we need the detailed research and actions to be taken. And as I said again, the smart brains are having this privilege to dig into this and find some new ideas for the betterment of our future. Not only your big actions or big researches will be responsible or will contribute towards the emission or to stop the emission, but the small steps taken by you and your small good habits can also contribute to it. Say, like, if you stop wasting water, the pumping costs will be reduced and so the electricity will be reduced. If you'll stop wasting the electricity unnecessary, you can save somehow some percent of CO2 from the environment. If you will walk for short distance rather than taking vehicle, it will lead to less air pollution and less emission of gases. At the same time, you will stay fit and somewhere you will contribute 0.0001% towards the carbon reduction. So I think this awareness is much needed for today's generation and the further coming generation. So why CCUS is vital for India? As I said, India is the third largest emitter. Even being the third largest emitter, we have only one single facility, one pilot facility to treat the CCUS, to capture the carbon and to make something good out of it. And we Indians, the smart brains, are lagging technologically behind to meet this target. What is the reason behind this? Why we are lagging behind as compared to US, China, Japan? The reason is very simple: lack of awareness, brain drain, lack of studies, hiding of records and issues. This could be the possible several reasons that we are lagging behind. Our generation is running or diverted towards something else rather than the technological aspect. And also I would say brain drain is the biggest cause because in our country, because we are utilizing our ideas to go in some other country and work for them rather than utilizing it in our country. So and in our country, very less people are aware that carbon is such a big problem that can lead us to several disasters to our country. And right now, it needs much attention of us as compared to other things. Here in this graph, you can see these red dots are representing pilot and demonstration studies which are under operation or research phase, whereas the blue dots representing the pilot and demonstration studies which are completed. So where you can find India here. India has only single pilot dam demonstration study which is completed and implemented right now. Tuticorin Thermal Power Station at Tuticorin near Bay of Bengal in southern part of India has this single facility for CCS. That is also not CCUS, for CCS. CCS is the integral part of CCUS. So in Tuticorin Thermal Power Station, the steps has been taken. They are converting the captured CO2 into baking soda and has the capacity to treat 60,000 tons of CO2 per year. It is a great capacity, but more actions are needed in India so that we can stand with the world outside. Right? Here in this slide, we can see the several sectors in which the CO2 emission is much higher. So the biggest sector is energy generation. The power generation is the sector where the emission is the maximum. The other sectors like iron and steel industry, transportation, construction, agricultural, cement industry, these are also contributing, but it is less as compared to the energy generation sector. This graph here is representing the global scenario, while in India, the parameters are somehow same. The percentage emission is somehow same. Energy sector is leading with 73%, and there is a huge demand to set up the CCS power station, CCS capture station, so that we can treat the carbon and save the environment. So what are the actual steps and solution for CCUS? CCUS is a broad chain. The first step which consists is to capture the carbon. To capture the carbon, first we have to identify the large point sources. We have to identify the point sources. From point sources, fossil fuel generation facilities, or industrial emission, we can capture the CO2. After capturing CO2, it is our duty either to store it or to utilize it. We cannot leave the captured CO2 as it, or otherwise it will be leaked and again it will release into the environment. It will cause the same effect. So our efforts will be of no use. So after capture, our responsibility to store it. Again, for storage or sequestration, there are numerous techniques available, such as geological storage, ocean storage, or industrial fixation. Once we will store it in geologically or inside the ocean, we cannot utilize or use it for next 50 to 70 years. So it is a very long-term process. But if we are fixing it at industrial level, we have to make some value-added products out of it. So this thing here, the development of value-added production is also having several gaps and needs research. So now to you students, I give a more challenging task for your major project dissertation. You can research on this and find something good to utilize the CO2 and to make some good products from CO2. You can bring some new ideas for this. As I said previously, that CCUS is a very long chain. So here the chain, we'll see the chain, how to start and what is the end of the CCUS. Not exactly CCUS, how to drain the CCUS. First of all, we have to identify the point sources and non-point sources. Point sources are nothing but the direct sources of CO2 from which we can directly get the CO2, and point sources are easy to identify. Non-point sources are which are a little tough to identify. We cannot recognize if it is a source of CO2 or not, and it will give us very less amount of CO2, but that is too will contribute to the environment hazard. After identification of point sources, the CO2 is captured via numerous technologies. There are different technologies like absorption, adsorption, membrane separation, etc. available to capture the CO2. It is somehow a big task, but not that as compared to the regeneration or scrubbing of CO2 from the captured material. After capture, here one more step is involved, that is scrubbing of CO2 from the captured material and its transportation. It is very crucial because it requires huge expenses and it may leak during the process, so our efforts may be wasted. So after capturing and scrubbing, there are two options. Either we can go for sequestration or for utilization. Sequestration, as I said, is very complex and very expensive process. It requires heavy machinery and technique and time to store the CO2 and to convert it into value-added products. We'll talk about this later, but this is a very complex process. So let's jump on utilization. Utilization of CO2 can be again done in two options, either by converting it into some other product or utilizing it as it is as CO2. CO2 can be utilized directly in food industries for fermentation, beverages, or aerated drinks, something like that. And converted CO2 can be converted CO2 can directly be made into mineralized chemicals or biologically. Here, mineralization are of two types. CO2 mineralization is of two types. First is mineral carbonation and second is carbon mineralization. These two terms seem very similar but has great significance individually. Mineral carbonation is a different term and carbon mineralization is a different term. From the mineralized carbon, we can either use it in concrete curing or construction work or making of building and construction units. And in the same way, by utilizing the minerals from the waste of iron and steel industries and thermal power station like fly ash, slag, etc., we are treating the waste from the industries. So it is beneficial for us in a two way. We are treating the waste and making the best out of it. In chemical industry, CO2 is used to form the several products, to form some fuels in polymerization, to produce the fertilizers, in the usage of nanomaterials and carbonates. CO2 is used to convert into such products so that it can be used in these industries. It has wide application in these industries. Also, CO2 can be used to develop the biological media and later it will be converted into algae. And these algae are further useful to develop some new materials or solutions or medias. So these are the wide applications of CO2 treated material or CO2 contained material, due to which we can treat the CO2, we can take the CO2 from one source and utilize it in some other sector, and the output will be less as compared to the emissions. Now let's talk about CO2 capture system. CO2 capture systems are further classified into four types depending upon the concentration of CO2 in the gas stream and the pressure in the gas stream. These are industrial separation, pre-combustion capture, post-combustion capture, and oxy-fuel combustion capture. Amongst which post-combustion capture has the major role because it is, as I said, thermal power station is the energy generation is the major contributor. Post-combustion happens in energy generation. So majorly we work on post-combustion, but other gaps are also there to be filled. Post-combustion CO2 capture is further classified into four types. Solvent-based, which is nothing but amine absorption of CO2 into the amine. Adsorbent-based, development of such adsorbent up to which CO2 can be stored temporarily and we can utilize it if needed. Membrane-based, there are some semi-permeable or permeable membranes which will allow the collection of CO2 and separate it from the nitrogen and other mixed gases. and hybrid systems. Hybrid systems are nothing but the combination of either membrane or adsorbent technique or membrane or solvent based technique. So here solvent based and adsorbent based techniques are nothing but absorption based solvent and adsorbent based solvent. What is the main difference between absorption and adsorption? Absorption is nothing but a technique in which the gas will directly diffuse into the liquid. So it will chemically react with the liquid and form some other compound, and later while regenerating it will come into its original phase or original form and release the CO2 from it. Absorption is the formation of such solid adsorbent on which the CO2 will rest for the particular time or temporarily on the surface of the adsorbent. It will not diffuse inside the adsorbent, but it will stay on the surface of the adsorbent, and further it can be utilized. Here on the right hand side, you can see there are several amines. We are now talking about absorption based technology, not adsorption, absorption based technology. And here are some amines which are widely used in industry to capture the CO2, some primary, secondary, tertiary, and hindered amines. So MEA, MDA, AMP, these are very common amines which are used industrially to capture the CO2 with this formula. And MEA amongst all has the better performance for absorption and regeneration also. It is also less corrosive and less harmful as compared to the other amines. At CSIR NEERI, we have conducted several studies based on the absorption technique. Here on the left hand side, you can see there are two columns in which the blue dots are nothing but CO2 and the yellow dots are amines. This first column here is absorption column or packed column. In absorption column, the CO2 rich gas, the gas which contains higher concentration of CO2 is diffused from the bottom, while the lean amine, which do not contain CO2 initially, which is pure amine, is coming from the top. There is a particular packing height provided in the column, which is offering the resistance to the liquid and also increasing the hold up time. In between the packing, the diffusion is taking place. The lean gas which we call having less CO2 will release, and the amine which contains CO2, we will send it to a scrubber or stripper or regenerator. Once it will come into regeneration section, we will heat it at a particular temperature. We have done several Sorry for the interruption. There's a power cut at my side.
Oh, that's okay. Not an issue. It happens.
Okay. So where were we? So we were here. So as I was talking that at CSI Miri, we have developed one biogenic molecule which has 3.5 times better absorption as compared to MEA, which is the bioevent industrially right now. We have developed one molecule which has better capacity as compared to MEA. It also has better regeneration capacity as compared to MEA. In this graph here, you can see this is for MEA and this is for B. This for biogenic molecule BACD. So this is for BACD. MEA is getting saturated within first 500 minutes, while BACD is taking some time after achieving some great amount, I would say, great amount of CO2. Then it will start saturating, and then once it will completely saturated, this line is coming straight like this. Here in this graph, we can see the desorption capacity of solvents, and this graph is water. It requires large 781 kilowatt of energy, 781 watt of energy to get dissolved of CO2, while MEA requires 314.93, that is 315 watt of amount of energy, while BioCD requires less energy as compared to both of them. Here in this picture, you can see our lab scale setup of absorption column for gas capture, for CO2 capture. This is the collection tank, and above here is the feed tank of amine. And behind this rack, there is a cylinder which contains CO2, and the countercurrent exchange of CO2 takes place in between this packing height. The BioCD I'm talking about, we have tested it through several parameters. It is highly selective. It is thermally stable. It is abundantly available in nature as we have enriched it from some natural things. It is soluble in water. It is less corrosive as compared to non-volatile solution for future. Into building materials. Nowadays, it is in trend to bubble the CO2 in the slurry, which we are using, cement slurries or cement and sand slurries, which we are using for construction purpose. It is one way. It is providing strength to the material and the walls, and it is also a good way to drain the CO2 somewhere for some time, at least for some time, not for permanent time, but for some time. Even all these sequestration and utilization technologies have some issues, such as huge transportation costs, long-term impacts, but these are not known. Several environmental concerns, and demonstration is still needed. There are several gaps which are need to be filled. Apart from the carbon capture, working on one technology into which we are utilizing to make some value other than capturing it, then regenerating it, and then converting it. We have mixed all these steps together, and we are somehow generating a good minerals, carbonated minerals from the directly captured CO2. But this So geological sequestration may be onshore or offshore. The technologies are not proven feasible yet, but the enhanced soil recovery is a advanced stage of it. It requires specific conditions and gas spill formation, but these are, again, I said it cannot be feasible for unminable coal beds. So we cannot sequester the CO2 into unminable coal beds. And eventually, the total reduction of emission can be depends on the fraction of CO2, the increased CO2 rate production, transportation and storage of CO2, the fraction of CO2 retained in storage over the long term. While doing all these studies and studying all these parameters, what I have found is no single technology is an option to stop or to prevent the emission of CO2 to achieve the global stabilization. So we have to work on several numerous technologies to achieve this goal. We have a long way to go, not for us, but for the survival of our future generation. Finally, I would like to thank Dr. of the department and senior principal scientist at NERI for providing me the opportunity to conduct studies on this thing, and CSR NERI. I'm grateful to CSR NERI for providing me all the advanced technologies and equipment required for the studies. Thank you.
Thank you so much for this presentation, Kate. This was a really good session, and you presented a lot of facts.
Sorry, due to
which were like not known to us. Although, yeah, that issues happen sometimes. Although it is manageable, it is good that you were able to come back after 5 minutes, because I was thinking that maybe it will take much longer than that. Because of the monsoons and all those things, these things can be long in terms of lag. About this technology, I wanted to ask you that when we were studying, or even while we are teaching, we always tell that CCU is kind of uh, intensive process in terms of economy. Like you have to invest a lot for carbon capture and then sequestration. Uh, so, is there any economical way to do this, like carbon capture and usage, other than sequestration? Like you have shown that sequestration is a different technology and this CCUS is a different technology. Hello.
Hello. Yes, am I audible?
Yeah. Yes, you're audible. I was asking that we have heard that carbon sequestration is like economically very intensive. You need to invest a lot for the sequestration of carbon. How
Sir, will you
CCUS
please
is like
come again?
Yes, sure.
Will you please come again? Yeah.
Yeah, like we have read that carbon sequestration is economically intensive. Like we have to invest a lot in the beginning.
Yes.
Uh,
Yes.
so is the CCUS a bit more economical than sequestration? And what are the economic terms in
Okay.
this?
Yes, sir. So what you're talking about is definitely correct, because it definitely requires huge amount to invest inside it, but it will all be funded by the government. First of all, at smaller scale in a college lab, you can conduct several studies to like uh, you can have, if you have some ideas, you can several conduct studies, and if that technology is feasible and will prove best, so you can get the funds from the government. There are several organizations available, and from which you can get the funds and you can carry out your studies further.
Okay, and I was about to come to the next question, which is
Yeah.
of the same kind, that can we do CCUS in terms of a major project for BTech, or it will be suitable for the master program, because we have been
Okay.
done
So
like we have to have some software as well, right, for this calculation part.
I was about to say this during the presentation only, that students, final year students nowadays are like searching on Google major project ideas for chemical engineers, or they are searching their senior dissertations for ideas of major projects. But that should not be the case, because we have many technologies awaited to be researched on, and it is not necessarily it could be done on for PhD or MTech only. We can do at students level. We can study some researches. We can carry out some researches for major project dissertation. For example, say the paper pulp. If we treat some paper with water and then we will try to bubble some CO2 in it, who knows that it can take CO2, and it can be a good idea for a major project also. It can live a huge dissertation program also. So some that small ideas can be taken up for the major project.
Right, like we can have some ideas and try them in the lab scale, and
then we
not
can
on,
implement on the
then we
larger
can
scale.
implement. Yes, right. This can be done, because usually I see CCUS program or project being done for the masters, like in IITs and NITs. So
Yeah.
in BTech, I have not seen
Such projects.
carbon capture that much to that much extent.
Yeah.
And what are the kind of does this technology also use some mathematical modeling for the calculation, and
Yeah.
how do we design this thing?
See, I'm not aware about like you're in university, but there are several universities who are providing the student version of some softwares like Spain or some mathematical modeling software. So using that, we can conduct these studies, or we can take the help from those universities which are using this model. Also, there are numerous, I would say, research papers available from which we can extract the ideas and even mathematical modeling ideas from the research papers and implement it on our studies. So it is possible through mathematical modeling, but we just need the source. But SPAN plus and other models are very expensive, so
Right.
it is quite difficult to get them.
Yes, in the college level, it is difficult. We basically prefer for a trial version or some demo version if it is available.
Yes,
Because
yes, definitely.
otherwise the cost does not come into feasibility.
Yes.
And there's one more question about carbon capture which I have. Like you mentioned that India has one site in Tuticorin,
Yeah, Tuticorin thermal power station.
where it is having this
Pilot
CCUS
facility.
plus sequestration. Yes. So are there any other sites which you know, or like potential sites which can be or explored about this carbon capture in India?
In India, I am not aware of that. One study has been conducted by IIT Delhi. There is a collab project of IIT Delhi, Thermax, and CSI NERI. So you can get to see some activity at IIT Delhi also, and I think IIT Powai also has one setup for carbon capture on lab scale. So you can visit there to if you want to see the CCUS. Or there is open day. There are several times. There is an open day at NERI where anybody can visit to NERI to check the projects going on, whatever the ideas are being cooking inside the NERI. So on open day, you can visit NERI also.
Okay, like I will try to check the open day of NEERI because this is a research.
Definitely, I will inform you if there is one.
Yes, yes, I will take the follow up about it. Well, that will be a good opportunity to actually visit this organization and see the research that is going on. And because sometimes students are only aware about the market and the products, but they are not aware about the research going on in our field.
And research is the main base of all this market and industry.
Those were the questions which I had. On the behalf of the Department of Chemical Engineering, Paris University, I would like to say a good session about carbon capture, which is a upcoming technology. Since we know that the global warming and we have to save our environment, so this technology can be explored more so that we save our planet and meet the environmental goals as well. Because agree, it is almost, it cannot be converted back or it cannot be pulled back. So this carbon capture will be a great source to control the temperature rise of the climate. Um, Thank you so much, Katie. It was really nice to have you as our guest. It was
Thank you,
our honor
Shivam.
to have you as our guest.
Thank you so much, sir. Thank you for inviting me. I'm honored to be here.
Thank you. Thank you.
Have a good day. Shall we call it off for a day? Are
Yes,
we
yes,
having some
sure.
more questions?
You too have a nice day, and we can.
Call it off for a day. Okay.
No, I think those are all. Yeah, we can call it off for that for now.
Okay, okay, sir. Goodbye.